Okay, we're going to be looking at 13.4, finding probabilities of compound events. So to get started, the essential question, when do you know when to add probabilities and when do you multiply probabilities? So this will be the key issue, and that's both related to the and the or expressions. And we'll look at some examples. Now this early terminology you should have already looked at. I'm going to look at it again here real quick. So double check the handout that you got in class to see if you've got these definitions down. If not, fill them in so that as we go through and talk about the probability, it makes sense. So we have a compound event. That's where it combines two or more events using those words, and, or the word or. And associated with the and the or is how we're going to know whether to multiply or add. And we'll look at examples of word problems and pick out these words. So if you see the word and, you need to start thinking multiply. If you see the word or, you need to start thinking of adding. And then there are some slight variations about the multiplying and adding equations that we're going to look at. But in general, and you'll multiply or you're going to add. So mutually exclusive events are disjoint. That means there are no outcomes in common, two totally separate groups of objects or individuals. Overlapping events, at least one object or individual is in common to the two different groups. So they belong to both groups at the same time. Independent events is the occurrence of one event having no effect on the occurrence of the other. So they're not affecting each other. One can happen and the other one's not going to change at all. So they don't affect each other. Dependent events. So that's the occurrence of one event affecting the occurrence of the other. So if one thing happens, that changes the probability of something else happening. So there is a direct relationship to that. So we're going to look at some examples. So we're looking at the mutually exclusive. So that's the probability of A or B happening. So those are just two events. I haven't defined what A or B is, but if we know what A is and if we know what B is, then to find the probability of one of them happening, either A or B, you would just add the two probabilities. Okay? So I have an example, an event A, roll a 3. Event B, we're going to roll an even number. Okay? So there's only one way to get a 3. This is a regular 6-sided number cube. So there's only one way to get a 3. That's, you get the 3. If you roll an even number, that's a 2, a 4, or a 6. So there are 3 ways to get an even number. So it would look like this. You also have a couple other numbers on the number cube that are not part of these two groups. So this is just a Venn diagram to give you a picture how they are separate. Okay, the 3 is not part of the B group because the B is all even numbers, and the 3 is not even. The even numbers, the 2, 4, 6, is not a part of the A group because that is just the 3. So this is what it means by being disjoint. You have two totally separate groups. So we want to find the probability of a 3 or an even number. So if we go back to our formula, it says that if they are disjoint events, you just take the probability of the first one happening and you add the probability of the second happening. So the probability of a 3 plus the probability of an even number. Probability of a 3. So how many sides on a number cube total? There are 6 sides. How many ways can you get a 3? There's only one. So the probability of getting a 3 is 1/6. Plus probability of an even number. How many sides are on the number cube? There are 6. How many of those sides have an even number? 1, 2, 3. There are 3 even numbers on a number cube. So that's 3 out of 6. So you add those together. You get 4/6. Make sure you simplify your fraction. 2/3. So the probability of a 3 or an even number is 2/3. Okay, so now we're going to take a look at overlapping events, the probability of A or B happening when there's some overlap. So we start the same way as we do before. So probability of A plus the probability of B, so we add the two probabilities, but because there's overlap, that means they have something in common. So we have to subtract this extra piece, which is the piece that they have in common. So it gets counted twice. We count it when we do the probability of A, and then we count it again when we do the probability of B. So then we have to subtract the second time that we counted. So let's take a look at an example. Event A, rolling an odd number. So our odd numbers are 1, 3, and 5. So those are our odd numbers. Rolling a prime number. So prime numbers are numbers that you can divide by 1 and itself, and that's it. So our prime numbers are 2, 3, and 5. So now we want to look and see where we have our overlap. So let's look at our diagram. So in circle A, notice we have a 1, 3, and a 5, all in circle A. In circle B, we have a 2, 3, and a 5, all in circle B. But there's this middle piece right here. The 3 and the 5 are in both circles. So that is our overlap. And then we still have a 4 and a 6. So what we want to do is find the probability of an odd or a prime number. So what we have to do is find the probability of getting an odd. We're going to add the probability of getting a prime. Then we have to subtract the probability of getting both an odd and prime number. Let's take a look at the probability of getting an odd number. How many total numbers are there on a number cube? There are 6. 3 of them are odd. So right there, the 1, the 3, and the 5. So there are 3 numbers that are odd. We are going to add the prime probability. So again, 6 numbers on the number cube. 3 of them are prime. Now, if you noticed, some of those numbers we counted twice. When I counted the odd numbers, I counted the 3 and the 5 twice. When I counted the even or the prime numbers, I counted the 3 and the 5 again. Okay, so I counted the 3 and the 5, and I counted the 3 and the 5 again. So how many numbers are there that we counted twice? There are 2 numbers, the 3 and the 5. We counted the 3 twice, we counted the 5 twice. So there are 2 numbers that we counted twice. So that's 2 out of 6. So then you do the adding and subtracting. So 3 plus 3 is 6, minus 2 gives us 4 over 6, which again is 2/3. So the probability of an odd or a prime number is 2/3. So this is what we do when our question is an OR question. Okay, you add probabilities, and sometimes there's this subtraction component if there's overlap. Next, independent events and dependent events. Okay, we're going to look at these in a number of different ways. For the independent events, probability of A and B. So that's just the probability of A times the probability of B. So we multiply. When it's an and, we multiply. So here's an example. We're going to choose 2 marbles from our circle, and that is with replacement. So I pick one, I record the color, I put it back, and then I pick another one. So we're picking twice, but we put the first one back. So let's find the probability we get a green and a blue. A green and a blue. So it's an and, so that means we multiply the probability of green times the probability of blue. Since I'm putting the first one back, the probability of blue isn't going to change at any time during the selection process. So the probability of green, you count the green ones, and we have 2. So here's our 2 green ones. So that's 2 out of, and then you find the total, 10 times the probability of blue. Since we put the green back, there are still 10 in the circle, and 3 of them are blue. Now, since we are multiplying, it is helpful to simplify your fractions before you multiply. So the 2 over 10 is 1/5 times 3 over 10. So if you recall on the previous slide, we do not simplify because you need a common denominator to add or subtract. When you multiply, it is more convenient to simplify your fractions. You could wait till the end and just get your answer and then simplify your answer, or simplify first while the numbers are small and then multiply. So now 1 times 3 is 3, 5 times 10 is 50. So the probability of getting a green on the first draw, putting it back, and getting a blue on the second draw is 3 out of 50. Now, dependent events. Dependent events pretty much in general is the same thing. It's an and question, and you're multiplying. Okay? The probability of B given A is just saying that this probability of B is going to change based on what event A was. Let's look at an example. It helps to explain what that means. So here we have an example again. There's a few different colors in there, so be careful with the selection. This time we're going to choose 2 without replacement, which means I pick one, I keep it, and then I go and pick a second one. Okay, so let's find the probability of getting a green and red. So that would be the probability of getting a green. Then when I get that first green one, I'm going to keep it and multiply the probability of getting a red, given that I got a green the first time. So, probability of green. There are 2 greens with a total of 10 in the bag. So 2 out of 10 times the probability of red. Now remember, I kept the first one that I drew. So now, how many are in the bag? We only have 9. The first one I picked was a green one. I had a 2 out of 10 probability that I got green. Now, there are only 9 left in the bag, so what's the probability I get red? 1. Only one of them is red. So now we multiply, or you can simplify first. The 2 over 10 is the same as 1 over 5 times 1 over 9, which is 1 over 45. So the probability of getting a green and red without replacement is 1 out of 45.